Okay, here we go. We're on Edpuzzle. I'm logged into my account, and here is my assignment about plate tectonics. So as you can see here, I have prevented students from skipping. Also, I have assigned this assignment to Class A over here. So let me watch it as a student, and I'll show you what the video looks like. Okay, let's click play, and as you can see, I can't skip.
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust.
Remember that although the plates are riding on top of the mantle is a solid body of rock, not a liquid.
Converging currents drive plates into each other, diverging currents pull them apart.
Okay, here's a little comment that I've got. Great. Talks about transform boundaries. Continue.
This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental land masses, the thinner of the two plates bends and slides under the other.
Okay, there's another question here. It says, which type of plate boundary will cause subduction of one plate beneath another? And the correct answer would be a convergent plate boundary with one oceanic plate and one continental plate. Continue.
As the edge of the seafloor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster the remaining plate behind it moves.
Okay, so what causes subducted oceanic plates to speed up over time? Once the plate is partially subducted, gravity helps pull the plate into the Earth at a faster rate. Great. Submit and continue.
You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them.
Okay, true or false? Subducting oceanic plates help drive convection within the mantle. True. What is the name of the plate boundary where two plates are being pulled apart? That would be a divergent plate boundary. Submit and continue.
Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
Okay, so that's my screencast. Now let's go back. And then if we click progress, great. Here's the results from what I just did. If I wanted to, I could go in here and mark this answer as correct. Then it gives me a 100%. I'm going to go back to the results page, and then here I can click export results. And down here it'll export it as a Excel document. So if I make these all the right size, then it'll show me the grades once multiple people have submitted the video. So that's a little bit about my video. Hope you guys enjoyed it. Thanks.